All right, we have 5-7 today, the quadratic formula. All right, finally getting there. I don't know if you've heard other people talk about it, but it's kind of like the Pythagorean theorem, right? It's one of those formulas that people remember having to use. So our objectives today are to solve quadratic equations using the quadratic formula and to solve some real-world applications involving the quadratic equation as well. So first of all, the quadratic formula. If ax squared plus bx plus c equals 0, where a, b, and c are elements of the real numbers, and a is not 0, then we're going to use the quadratic formula here. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, the wonderful thing about the quadratic formula is it can be used to solve any quadratic equation, much like completing the square was, but it tends to be a little bit neater. There's a box over here, right? This box shows you how to derive the quadratic formula. Okay, how to start out at ax squared plus bx plus c equals 0. And to complete the square, you do some completing the square, all this stuff, and then you get to the quadratic formula at the end. Okay, so it's just a shortcut to completing the square, quite honestly. All right, so we're going to dive right in to using the quadratic formula. So actually, let me move this up so I have a little bit more space. I want to keep our formula there, the quadratic formula. And example 1, we're going to solve x squared plus 4 equals 5x. So step 1, we want to write the equation in standard form, okay, always, and identify the values of a, b, and c. Because we're going to substitute a, b, and c into the quadratic formula and then simplify it. Okay, so in order to do this, we have x squared plus 4 equals 5x. Not in standard form, so we need to subtract the 5x from both sides and write it in standard form. So x squared minus 5x plus 4 equals 0. So we've got it in that standard form here now. Okay, so once we have that, we want to identify a, b, and c. So our a is 1, right? We don't write it, so it's 1. That's our a value. Our b value, what is our b value here? Good. Our b is negative 5. Okay, so that's our b value. And what's our c value? Perfect, a positive 4. Okay, so we're going to plug those in. We're going to substitute those into this formula. So again, we've got x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x is equal to negative b. b is negative 5. So negative 5. Okay, plus or minus the square root of b squared. Again, b is negative 5. So we're going to have negative 5 squared minus 4 times a, which is 1, times c, which is 4. I'll extend my square root sign. All divided by 2a, which is 1. All right, so, in the future, you don't have to write the ones, I get that. But in showing you the notes, I want to make sure you're understanding that we're putting every single component in there and where it's coming from. Okay, so then let's move on. Negative times negative 5 gives us a positive 5, plus or minus the square root. Negative 5 squared is 25, minus 4 times 1 is 4. 4 times 4 is 16. Okay, all divided by 2 times 1, which is 2. And this time I might erase a little bit. Okay, so then I'm just going to extend this on and put an equal sign there so we can do some math. So we've got 5 plus or minus 25 minus 16, so the square root of 9, 5 plus or minus the square root of 9, divided by 2, which is going to equal 5 plus or minus, what's the square root of 9? Great, 3, all divided by 2. Okay, so this is like a partial solution. Okay, but then we actually need to solve it. Okay, so we're going to do 5 plus 3 divided by 2 and 5 minus 3 divided by 2. So 5 plus 3 is 8, divided by 2 is 4. 5 minus 3 is 2, divided by 2, which is 1. So my x equals 4 or 1. Okay, those are my solutions. Okay, so remember, this equation could have been solved by factoring, possibly. Could have been solved by completing the square. Could have been solved by any of those methods, but I'm showing you the newest one, which is the quadratic formula. Okay, so let's look at example 2, because every time we're just plugging them into this equation. So example 2, we've got 4x squared plus 12x equals 11. We want to state both the exact solutions and the decimal approximations to the nearest hundredth. So this one's telling us we couldn't have factored this one. We could have used completing the square, but if we're going to get decimals, there's no way we could have factored it. Okay, so first, step 1 was get it into standard form. So we're going to subtract 11 from both sides and end up with 4x squared plus 12x minus 11 equals 0. And that's perfect, exactly what we want. Okay, identify our A. What is A equal to? Perfect, 4. B, what's B equal to? Excellent, 12. And C, what is C equal to? Negative 11. Glorious. Okay, because we're going to plug these into the quadratic formula. So we've got x is equal to, you get it in there, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so x is going to be equal to negative b, which is 12. Oh, my color didn't change. So negative 12 plus or minus the square root of b, which is 12. So b squared minus 4 times a, which is 4, times c, which is negative 11, all over 2 times a, which is 4. All right. Good stuff there. So we're going to have x is equal to negative 12 plus or minus the square root of 12 squared is 144 minus, okay, so, or actually we might not put that yet, negative 4 times 4 is negative 16. Negative 16 times negative 11 is a positive 176. All divided by 2 times 4, which is 8. Okay, so that's going to equal our negative 12 plus or minus the square root. 144 plus 176 is 320 divided by 8. Okay, so we need to simplify this radical here. So I'm going to do some division by primes. So 320 divided by 2, because I can cut that down easily, right? 320 divided by 2. 2 goes into 3 once. We subtract 2, we have 1 left over. The 2 goes 6 times. Bring down our 0. Okay, if you could do the mental math, you don't have to show this. I just wanted to show it. So we'll divide by 2 again, we get 80. We can divide by 2 again, we get 40. 2 again, we get 20. divided by 2 is 10, divided by 2 is 5. All right, remember we're always looking for groups of 2 because we're doing the square root. So I've got 2 groups of 2 I could pull out. So this is 2 times 2 times 2, pardon me, 3 groups of 2, and the square root of 5, right? That 5 is going to stay under the square root because I don't have a match for that. Okay, so 2 times 2 is 4. 4 times 2 is 8. So this is equivalent to 8 times the square root of 5. Okay, the square root of 320 is equal to 8 times the square root of 5. So that means x is equal to negative 12 plus or minus 8 times the square root of 5 divided by 8. We want to simplify this, right? These are even numbers, so we could divide them all by 2. Okay, negative 12 divided by 2 would be negative 6, plus or minus 8 divided by 2 would be 4 times the square root of 5. 8 divided by 2 is 4. We could divide them all again, right, by 2 and simplify a little further. Negative 6 divided by 2 is negative 3, plus or minus 4 divided by 2 is 2. Notice the square root of 5 never changes. 4 divided by 2 is 2. So this is the most simplified exact solution that we can give. And then we need our decimal approximations. So remember, that's when you can use your calculator, and you're going to add 1 and subtract 1. So in your calculator, let me clear it out here from the last one. You're going to have negative 3 plus 2 times the square root of 5, right? Oh, negative 3 plus 2 times the square root of 5. And I should have put some parentheses in there. So I can hit enter and then say divided by 2 equals. So that's going to give me what it would look like total. Remember, they changed the order in this calculator. All right, and then I have a toggle button on this calculator right down here. That's going to change my answer to a decimal and give me 0.736. I'm going to the nearest hundredth. So this is 0.74. So x is approximately 0.74. And I would do the same thing for the minus 2 times the square root of 5. And I would get negative 3.74. Okay, so there you go. You have your exact answers as well as your decimal approximations there. Great. In example 3, we're going to solve it using the quadratic formula, and we're going to check our solutions this time. Okay, so what's our A? Good, it's 1. What's our B? Excellent, negative 10. And what's our C? Perfect, 29. All right, so we're going to plug them in that equation. So x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Right, it's a mouthful. So x is equal to negative 10. I'm not going to color code it this time, but b is negative 10 plus or minus the square root of b, which is negative 10 squared, minus 4 times a, which is 1, times c, which is 29, all over 2a, and a is 1. Okay, so x is equal to a negative times negative 10 is a positive 10, plus or minus negative 10 squared is 100, minus 4 times 1 is 4, 4 times 29 is 116, all divided by 2 times 1 is 2. So we've got 10 plus or minus the square root of 100 minus 16 is negative 16 all over 2. All right, again, we know how to simplify this, right? So this is going to equal 10 plus or minus. The square root of 16 is 4, and it's a negative, so we have I. So 10 plus or minus this 4i divided by 2, which again can be simplified further. 10 divided by 2 is 5, plus or minus 4 divided by 2 is 2i. So 5 plus or minus 2i. Okay, then it says to check the solution, right? Check your solutions. Well, if that's the case, this is your solution. This is your x, right? In order to check it, we're going to plug it back into the equation. So we're going to have our x is 5 plus, we're going to just pick one of them at a time. So 5 plus 2i squared minus 10 times 5 plus 2i plus 29 should equal 0. Okay, so I'm going to do some work down here. So 5 plus 2i, to square that, 5 plus 2i. 5 times 5 is 25. 5 times 2i is positive 10i. 2i plus 5, or times 5 is 10i. And 2i times 2i is 4i squared. So then we have 25. We combine our like terms. So plus 20i plus 4 times I squared is negative 1. Okay, so then we have 25 plus 20i plus negative 4. So let me make that minus 4. 25 minus 4 is 21 plus 20i. Okay, so that was just for this step. So then we've got 21 plus 20i. Okay, negative 10 times 5 is going to be minus 50. Negative 10 times 2i is minus 20i plus 29 equals 0. Okay, so then we have plus 20i minus 20i. Those cancel. 21, I'm just going to do the addition first. 21 plus 29 is going to give you 50 minus 50 equals 0, which means 0 equals 0. So it checks out. That is the correct answer. Now, when it says check the solutions, you should check both of them, the 5 plus 2i as well as the 5 minus 2i. But we've ran out of room. But just know when it says check the solutions, you're checking both of them in this case. All right, let's get to example 4. Imaginary roots of quadratic equations are always conjugates. Okay, so if you think about when we've looked at some conjugates, that might be a helpful information to know. So example 4, looking at this real world application. If the length to width ratio of a rectangle is such that removing a square from one end results in a new rectangle with the same length to width ratio, the rectangle is a golden rectangle, and the length to width ratio is the golden ratio. I was thinking theta, but this may not actually be theta. So let me pause and look for a minute. Okay, I was right. It's not theta, it's phi. Phi. Okay, but I had theta in my mind, and then I looked at it. I was like, that's not theta, that's phi. But I wanted to confirm. All right, so it's called the golden ratio phi. So we're going to use the diagram illustrating this definition to determine the exact value of phi and its decimal approximation to the nearest thousandth. Okay, so let's make some sense of this. Okay, it says if the length to width ratio of the rectangle is such that removing a square from one end results in a new rectangle with the same length to width ratio. Okay, so our first rectangle is here, right? And we're talking a length to width ratio. So that would be phi over 1. Does that make sense? Our length to our width ratio. Okay, now if we remove a square from one end and it results in a new rectangle, okay, so here's our new rectangle with the same length to width ratio. Okay, it doesn't really look the same because this time the length of our rectangle is 1 and our width of the rectangle is theta minus 1. So remember, like if I turn this sideways, remember length is always the longest side. So when we're talking about length, we have to keep the longest side as the length. Okay, so it has this ratio, which would be 1 over theta minus 1, which these two ratios do not look the same. But it's telling us they are the same, which is why we can put the equality sign or the equal sign between them. Okay, it says use the diagram illustrating this definition to determine the exact value of phi and its decimal approximation to the nearest 0. Okay, so we've got this proportion, right? We've got phi over 1 is equal to 1 over phi minus 1. So we have a proportion. Do you remember how to solve a proportion? It's been a while. We do cross products, right? So we have phi times phi minus 1 equals 1 times 1. So phi times phi is going to be phi squared minus phi times negative 1, so it's going to be minus phi equals 1 times 1 is 1. Okay, so we've got that, which looks a lot like a quadratic. Remember, x squared plus b, well, we have ax squared plus bx plus c equals 0. So we need it to equal 0. So let's subtract 1 from both sides. Phi squared minus phi minus 1 equals 0. All right, so now we've got a quadratic. Awesome. So once we have a quadratic, we need to determine our a, which is 1. Our b value, that's a little trickier. What's that one? Excellent. It's the negative 1, right? Negative phi. So this is negative 1. And what's our c value? Also negative 1. We got lots of 1s here. All right, so we're going to plug these into the quadratic formula. All right, one more time with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. It's good practice to say it out every time you write it, so then you'll remember it, because it will be on like your ACT, it'll be on your test at the end of the chapter. It's one of those things that's like the Pythagorean theorem. You're going to have to memorize the formula. All right, so our x is going to equal negative b. So negative b is negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 1, times c, which is negative 1, all divided by 2a, which is 1. So negative times negative 1 is 1, plus or minus the square root. Negative 1 squared is 1. We have negative 4 times 1 is negative 4. Negative 4 times negative 1 is a positive 4. Divided by 2 times 1, pardon me, is 2. So this is 1 plus or minus the square root of 5 divided by 2, which cannot be simplified any further. Pardon me, this is not, in this case, this would not be x though, would it? This would be phi. This is what our phi equals. Okay, so phi is equal to 1 plus or minus the square root of 5 divided by 2. And then we want the decimal approximations to the nearest thousandth this time. So the same thing, use your calculator, put that in there. And when you do, you're going to have phi is approximately, remember to use those wavy lines. When you do 5 plus, or 1 plus the square root of 5, it's going to get 1.618. Okay, and then I want to do the other one just to show you. Okay, so if you do your other one here, clear it out, we're going to have 1 minus the square root of 5 divided by 2. Okay, notice we've got negative 5 plus 1 divided by 2. And I'm going to toggle that to get our decimal. Notice I get a negative 0.618. Can I have a negative distance? Can I have a negative distance? So my answer here would be 1.618 and negative 0.618. But my question is, can I have a negative when it comes to finding the length of something? Can I have a negative? Absolutely not. So this one is not actually an option. Okay, you're just going to have one decimal approximation. That being said, can I have this minus down here? No, this would just be 1 plus the square root of 5 divided by 2 is the exact value. Okay, so there's only one answer in this case, because if we do real world application, we cannot have a length of a negative number. That is physically impossible. Okay, so then one last thing before I go, I know it's not on your paper, is for you to enjoy a little song. Got to do a few adjustments here. There we go.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
Enjoy.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
All right, have a great one. I will see you later.